So we are live. Welcome to the Connecticut chapter of Association's March 2017 chapter meeting. I'm not sure how many viewers we have tonight. We have a few coming in now. I'm just waiting. Our apologies for the delay. We had some technical difficulties. But I did post a message on Twitter to let us know, to let our networks know that we were having this. Kimber, do you have any updates to share with everyone before we get started?
Not really. Just want to welcome everybody to this event and then thank Meg and Andrea for being with us. We really appreciate you being here. Yeah, I guess we can start.
Yes. So our first guest speaker tonight is going to be Meg Davis from CodeHS. And then our second is going to TEALS. So if you have the link on the video, go in and kind of see what their presentation is going to be about. With a little summaries or abstracts they provided. Meg Davis, CodeHS. Meg, I'm going to hand it off to you.
All right, great, thank you. Oh, hi everyone. Again, my name is Meg. I'm here representing CodeHS. I just went ahead and shared my screen with you, so I hope that that worked and I hope you can hear me. Basically just a quick overview. CodeHS is a comprehensive teaching platform for computer science. So, we like to make sure that we have pretty much everything that a school or a district should need to start from scratch or totally revamp their computer science program. We have a 6 through 12 curriculum pathway. I pulled up our high school recommended pathways here. We also have professional development for training teachers, and we have a lot on the teacher tools and resources side too, as far as progress tracking, like other classroom management tools and lesson plans for all the lessons in all of our courses. So I'm going to walk through just some basics of the site here, and at the end I put up my contact information, so if anyone's interested in a more direct demo of the teacher membership, or wants to sign up for an account and start working through the material, feel free to reach out directly to me with some help on that. The first thing I pulled up here is our high school curriculum pathway. 2 year-long intro classes in programming. One of those is in JavaScript and one is in Python. Usually people start with our JavaScript course just because with Python seems like there's a bit more of a need for the basic algebra knowledge compared to this JavaScript class. So just it kind of depends on where specific students are at. There's definitely some flexibility as far as which one of those courses you wanted to offer first, or if you only wanted to offer one instead of the other, that's fine. And we also have both of the AP courses. And we're currently approved by College Board for both the student curriculum and the professional development. We have the year-long course, and we also have smaller review courses for students to do once they've finished working through the regular curriculum. Actually working with College Board on becoming an endorsed provider right now, so have some things to finalize there, but hopefully by the end of this month I'll be able to tell you that we're one of their endorsed providers. Another course you see here is Computing Ideas. This one is a bit more of a survey course. Typically, we actually see this at the middle school level, but we do have a few high schools that are doing it if they don't necessarily want their students to jump straight into an actual, full programming class. Computing Ideas covers a little bit of HTML and CSS and has other topics like, what is the internet, what's the history of the computer, and just a bit more focused on those high-level computer science concepts as opposed to being directly focused on programming. The way that we do professional development is that we have teacher courses that correlate directly with whatever student course they're planning to teach. So, for example, our teaching Intro to Computer Science, that's meant, generally for teachers who don't have much programming experience and are about to be teaching computer science for the first time. So it goes over some of the fundamentals of computer science and JavaScript, and then turns out to focus on, how do we grade our students' programs? How do we teach in a blended setting? And our other courses are, again, focused specifically on the student course that you're prepping to teach. So we have some that directly correlate with our AP courses. And we also have a secondary professional development course. So this is more geared either for a teacher who has already completed one of these here, or has just had a bit more computer science experience and is looking for something more focused on how to use the site well and how to deal with specific exercises that we have here. I pulled up a screenshot from the student side of the site. So here you can see that the first unit, this is called Programming with Carol. We're looking at our JavaScript course, but we actually start off all of our classes with Programming with Carol, which is a teaching programming language that we have. The idea here is that we want to help students begin thinking like a programmer and learning how to break down problems in the right way before they have to worry too much about the ins and outs of JavaScript and things like that. The general structure of the course is pretty self-paced. Students start each lesson with an instructional video, jump into a quiz. The quizzes are typically only 2 or 3 questions, and they're more of a gut check just to make sure that the student actually watched the video. And then after that, students will play around with an example, and most of the time they'll spend actually working on exercises in their code editor. The big red arrow you see here is just pointing at the resume button. The way that it saves the progress, whenever a student logs in, they can just hit resume and it will take them to the next exercise that they were working on. I've pulled up the student's code editor here. There's a couple things that they can do from here. Normally I'm doing more of a live demo where I can jump around the site, so we just have some arrows pointing at the things you can do. But students have a documents tab they can access if they maybe forget, oh, how exactly do I add a circle to the screen in JavaScript graphics, or how exactly is this specific function written? They can go check that out in the Docs tab whenever they need a reminder. We also have Help tab. So that's where students can ask their teacher questions, get responses to their questions from their teacher. And teachers can also get some information there, like when did the student start this exercise? When did they submit it for the first time? Have they submitted it more than once? And there's also a tab where you can check out the code history. So if you wanted to see, how many times has a student hit run code, how many different things have they tried out here, you can go find that information in the Help tab. I also pulled out the teacher side of the site here. So you can have really however many sections you need in different courses. As soon as you create one, it's just going to automatically populate a class code for you. So when you want to enroll students, you can just give them a link with the class code and it will take them to a page to create their own account and enroll in your class. Once they are enrolled, this is what your roster page would look like. This progress bar here for the overall course completion, that's part of the pro plan with our progress tracking. No matter what, though, you'll have a roster page and be able to look at a student's user page and view their code. Another thing you can do on CodeHS is write your own content. So we have a pretty big mix as far as teaching experience with computer science. Some teachers like to just stick with the year-long curriculum we have. Other teachers like to write their own exercises or even potentially their own units. So you have a lot of freedom here as far as writing your own exercises, quizzes, giving students free responses. You can upload videos from YouTube or Vimeo, and there's different programming languages you can do that in. JavaScript, Java, and Python, and HTML. We have courses in all of those. And if you were really branching out on your own and wanted to have them run something in processing or SQL or something like that, you can allow that to run on our site with the custom content. We also have a problem bank. If you're somewhere in between and you want to break from the curriculum, but you don't really want to go about writing your own exercises, or you just don't want to reinvent the wheel in case someone has already done what you're looking to do. So you can check out our problem bank and see other exercises written by CodeHS teachers. You can also filter this. You can see there's over 1,000 problems. There's even more than there was at the time I took the screenshot. So if you wanted to filter it on, JavaScript and for loops, then you can do that and make sure that you're checking out exercises that are actually relevant to what you're trying to help your students out with. Just to give you an idea of some of the differences between our free and our pro plans, I just pulled up a couple screenshots from the pro side of the site. I don't want to spend too much time on that, but just want to give you an idea of where the difference is so that if anyone wants to do a trial or a demo of it, you can know to reach out to me. With the pro plan, you'll have lesson plans for every single lesson. With the lesson plans, you'll be able to find teacher and student-facing handouts for some additional offline exercises. There are problem guides if you want to find some FAQ for specific exercises. Check out the solution code, see where students tend to get stuck. You can find that there. Our Intro to JavaScript and our AP Java classes both have online textbooks just to supplement what we already have. So you could jump to the online textbook from the lesson plan. And we also have progress tracking with Pro. So we have like 5 different progress tracking views. This is just one of them. This is a good place to go if you wanted to see, are any of my students skipping the videos, or did I tell any students to give an exercise a second try and they haven't done that yet? That's some of the information that you're able to get from here. There are also some grading features that are different. I've just pulled up an example here that would pull up the student's code next to the solution code for you, where you can compare those side by side. You can send messages along with the grade and work through a grading queue like this. Again, don't want to spend too much time going into every single thing, but just want to give you an idea of what's available. And if anyone wants a better demo of all those features, feel totally free to reach out to me directly. I put my business card here, so that's my phone number and my email. I spend a lot of the day on the phone and in video calls, so I might be hit or miss on the phone, but feel free to give me a try. And if I don't pick up, I'll call you back, or you can send an email to set something up. So, that's what I had here. I know that there's going to be a portion for some Q&A, so if anyone has any questions, send them on in.
Thank you, Meg.
Thank you, Meg. I am not seeing any questions come in.
All right, sounds good.
I just want to mention that I use your CodeHS for CSTA, and I find it very useful. So I like your dashboard a lot, and I think it offers a lot for teachers. So if anybody hasn't tried it, it's good to go look at it.
Oh, thank you. And we just released the review unit for that. So if you haven't had a chance to check that out, there's like 177 questions.
Okay, I haven't, but I will. Thank you for letting me know.
Cool, yeah. Thank you.
Thank you again, Meg. No questions are coming in. We do have some viewers, so if you submit questions to the chat on YouTube Live. Let's go ahead and let's move on to Andrea. So Andrea Russo from TEALS is on site. Welcome, Andrea.
Let me unmute myself and screen share with all of you. Let me just get that the right location. So hi, everybody. Thank you, the CSTA Connecticut chapter, for allowing me to come and speak to you guys today. And for all of you who are here that I spoke to at PAX, thank you for having a very busy weekend and then coming and listening to us talk today. My name is Andrea Russo. I'm the regional manager for TEALS here in Connecticut. And what I do is I help to build and grow sustainable computer science programs in the United States through TEALS. And we do that through a different kind of professional development model. But before I start to talk about that, I kind of just want to go through very quickly, and I hope this is speaking to the choir. We need computer science. You know, at this point, 84% of parents want it. 60% of administrators and teachers say it should be required. However, we have this gap in that there's only about 57,000 actual students taking the AP CSA course. You know, at this point, AP computer science and just computer science in general is as important as a student having a fundamental understanding of economics or statistics. Unfortunately, we are in between European history and art, and so we need to work in getting this changed. Knowing computer science is more than just understanding computational thinking. It really helps for democracy to have informed citizens, and the computational thinking is going to help a student in any area they want to study, whether they're going into actual computing, they're going into law, healthcare, even music. You need to have a fundamental understanding of computers in order to do your job in this day and age. Unfortunately, there are not enough computer science teachers. So these images are for the MIT Career Fair, and it is a $40,000 buy-in to just be at this career fair. Schools don't have that kind of money to get teachers available, and because we have this high demand for people who have computing skills, they are highly sought after in industry. So if you have a choice between becoming a teacher or going into a highly lucrative job in IT or computing, most often the schools don't win. And so because we don't have enough computer science teachers, there happens to be this perceived notion of not having computer science classes and students not even having a choice to take a computer science class. And unfortunately, this is no perceived demand. But luckily, like the CSTA chapter and like Code High School, you know, people are making these efforts to change this. And so TEALS works to build this by pairing people who are industry professionals with classrooms. The classroom teacher provides the content expertise in education, whereas the industry volunteer provides some content expertise. The students not only get to be exposed to content taught directly by industry professionals, but they also get exposure to careers in computing, and the teacher also gets exposure to careers in computing and which they might not have been aware with. And then the volunteer gets to have this wonderful experience of giving back to their local community, as well as building legacies in high schools. We do this model in a tapering effect. So our largest support model is the co-teaching model. And right from the start, the teacher really is taking care of the classroom management part. You know, they are the expert in education, and they will continue to be that educational expertise. And the volunteer is really there to help leading class instruction. And as the teacher feels more and more comfortable with the content knowledge, the industry professional begins to back off, and the teacher begins to lead more and more classroom. And in the classroom enrichment model, the teacher is very comfortable with the content material. However, they would still like to have the industry professional in their classroom, have that connection, allow students to be exposed to those jobs. And, you know, it's great to have a phone call away of someone to just bounce ideas off of, or maybe having another person in the room to help debug code or just, you know, grade presentations. We support a few. This is, I'm going to just run through this, the co-teaching model, lab support, classroom enrichment, just for the sake of time. We also do remote teaching. So if you don't have a industry volunteer who is in your local hub, we do this remote teaching through teleconferencing communication, kind of like we're doing right now, and that the volunteer can actually go and teach the class using those communications. The school I support currently in Connecticut, in Windham, Connecticut, uses this remote model. So one of the volunteers was actually in Switzerland for work, and he didn't want to miss the class. He still wanted to see his kids and, you know, talk about dedication. So he still used the Skype messaging, and he presented the lesson plan to the students. And, you know, of course, that was 5 minutes of distraction because the students wanted to ask about where he was, how was the Wi-Fi connection, all those fun things. But, you know, what an enriching experience for students. Not only are they learning this very useful technology that they'll probably have to use at work, but also kind of seeing how small technology really makes the world. So the first curriculum that we support is the Intro to Computer Science. This is a block-based programming language, and our curriculum has gone through several different iterations, but it's based off of UC Berkeley's Joy and Beauty of Computing. In this program, it's meant for students of all levels, and really just to be an introduction to the concepts of computing without having to worry about syntax. This can be taught as a one-semester course or a full year. If you teach it for the full year, the second semester would be taught in Python, which is a very syntax-light program. It is a great springboard to help students get prepared to go into the APCSA course. We support the APCS principles. So that's the new AP course. It is a broad concept course that students can kind of get a taste of all of the different courses they would take as a CS major. We don't support this in the co-teaching model. So in APCS principles, it would either be lab support or the consulting support. The teacher would need to go through a PD through a different provider. We support, at this point, 6 different curriculums for the APCS principles course. We also support the APCSA, which is and our curriculum is based off of the University of Washington's CSE 142, 143. And this is meant as a rigorous course for students who have strong skills and are good students. It is an AP course, so it is meant to be rigorous. I said that a few times just to emphasize that, you know, it is meant for a stronger student. We use the textbook, the Building Java Programs, and we support all models of this, and the Python really is a great springboard to bring you into this course. We teach all types of students. We are in public, charter, private, independent schools, rural, suburban. We're very proud to say that we are above industry average for diversity. And also our students are all different types of students, which I think is showing a different type of diversity, that it's not just a gamer who's in the computing class, but there is students who are in sports, there are academic groups in music. Besides having students take the course, we also really want to get students excited about computer science. We want them to enjoy it and spread the word that this is actually really engaging and fun. So we do things like college and career talks. All the students get to get a TEALS t-shirt. You know, the soccer team has a jersey. Why can't the computer science class have a jersey? And either the teacher or a student in the class can actually design the t-shirt themselves, which they enjoy doing. We offer field trips as well as links to different industry opportunities such as internships. So we have impacted many, many students, many places. We also have an online community. Our online community at this point is we use Piazza as our platform, which has over 100,000 people in it. And that's not just TEALS workers, but classroom teachers as well as the volunteers. And if you post any question at this point, there is a 37-minute return